In this lecture, we're going to explore some ideas associated with graphing. So let's just start at the beginning. As our example, we're going to graph, we'll label the points, this set. And the idea is we're just given a set of data, and what we're looking to do is try to visualize that data set. So first things I want to point out is we have a set of data. This is an ordered pair. Now, okay, that sounds obvious, but a pair meaning two, there's no reason you can't have an ordered triplet or more, and so on and so on. But to visualize ordered pairs are most useful. Ordered matters in a sense that minus 3, 4 is different from 4 minus 3. And again, that sounds obvious, but that's not necessarily the case. I mean, in probability theory, for example, they would mean exactly the same thing. Okay, so ordered pair, I'm not into introducing a lot of terminology, but I want to try to have enough terminology that it's useful. So minus 3, 4 is one ordered pair. We have another one, 4, 3, 5, 0, and the rest. Okay, by convention, okay, if we label our axes x and y, right, x has to take a number, a value. These are the possible choices for x. These are the possible choices for y. Okay, in the ordered pair, the first number goes to the x, and the second number is the y value. Okay, so the minus 3 would be the x value. So again, x would equal minus 3, take the x value. And 4 would take the y value. Y would equal 4. So that's what you have when you have an ordered pair, when we represent it as a point. Now we can go through the set and we could plot the second ordered pair on here, 4, 3. Again, the x value would be 4. The y value would be 3. And subsequently 5, 0 would appear here, minus 4, 3, and 0 minus 5. Now the question is, what is this a graph of? Now this particular set only has 5 points, and that's fine. There's nothing wrong with that. We're trying, though, to move up to, for example, the cases where our set contains infinitely many points. So clearly the picture is going to be helpful interpreting that solution. So what I'm trying to emphasize here is if we only had 5 points, can you look at that and tell me what shape that is? What is this a graph of? Right, so that's the question, right? So we're only able to plot a finite number of points, even if you're using a computer or a calculator. You can still only plot a finite number of points, and this is going to stick with us throughout the course. So do you have enough points to decipher what this picture is, to represent this picture? I don't think you really can here. In fact, it's a circle. I just took it as a circle with a center 0, radius 5, and but you couldn't get it from the data, right, from that set. So again, one of the reasons that we want to represent this graph of this set of ordered pairs is so that we can get a picture, right? So we can decide what the picture would be. And if we don't have enough points, we're kind of out of luck. So that's going to be one thing we're going to address. Okay? Now let's build on this idea. The whole idea here is that we're building on ideas, right? We don't have to reinvent the wheel every time. So what we want to do is, in this case, we want to determine whether each ordered pair is a solution to this equation. Now, it's an equation because there's an equal sign. That's what equation means. And by being a solution, we mean that if we put the x value, right, x has to take a value. As I said, x is a box. Something has to go in there, 1. X has to take a value. So if the x takes a value from the ordered pair, and y takes a value from the ordered pair, the question then is, are the two sides equal? Is this a true statement? Okay, and that's what we mean by a solution. If you plug in the ordered pair x and y values, is that a true statement? Well, let's take a look. Again, we're starting at the basics, it's fine. So our first ordered pair is minus 2, 3. So let's take a look. When we have minus 2, 3, we're saying that the x value is minus 2, right? It's the first in the pair. And the y value is 3 because it's the second in the pair, and that's the convention. Okay. And then the question is this equal if we substitute in there? Okay, so we'll plug in the x value minus 2 into the x slot and the y value into the y slot. And then the question is this equal, right? Is it equal? Well, you have to do some calculations. I don't know yet. And minus 14 doesn't equal 2, so no. Now, again, it's not necessarily good or bad. We got a little bit of an angry face. But the issue is it's not a solution. It is or it isn't. It's not a judgment call. It just isn't. Okay, so we can simply eliminate that point as being a solution. Minus 2, 3, the ordered pair is not a solution to this equation. That's fine. Now, how about 1, 1? How about that? Is that a solution? Well, again, we have x equals 1. We have y equals 1. And we will substitute into the equation and see if they're equal. So we plug them in. Let's take a think on this. And do a little algebra. And yes, they are equal. So x equals 1, y equals 1 works when substituted into the equation. So 1, 1 is in fact a solution. Right? Now, notice every x, y value on the coordinate plane, right, has a particular x and y value which you could plug into the equation. Now, there are infinitely many, but you could simply go down the whole coordinate plane, plug in every x and y value until you get all the ordered pairs. Now, that's impractical, and that's what we're going to have to do. So that's what this question is really, right? We want to graph the solution to this equation. What does that mean? So if we're going to graph an equation, how do we do that? Well, the first thing we want to do is we want to find the solution set. Now again, whether you write down the steps or not, you have to follow a procedure. What is a solution set? It's the set of all ordered pairs that satisfy the equation, right? All ordered pairs that satisfy this equation. Now, there are infinitely many ordered pairs, right? Infinitely many choices of x value and y values. And if you can simply plot, go through that entire list, you've got the solution set. Now, that's our problem. There are infinitely many. You can't do it. So what do we have to do to begin with? This isn't the final answer, but what do we do to begin with? Well, we're just going to make a table of x and y values, right? And we'll just plug in some x values and calculate y values such that that equation is true. Now, you can see the pros and cons of this. The pro, it's fairly easy. There's only 5 points. You could plot more. The con is there's only five x values here. I mean, there's infinitely many x, y values that satisfy that equation. We're plotting 5. That's kind of living dangerously. Secondly, how did I choose these x values? I mean, I could choose anything. Why did I choose these 5? Because I know the answer, and that's not a satisfactory answer either. So we're going to learn ways to deal with these shortcomings. I mean, sometimes this is the best you can do, but for a lot of prototypical problems, we have ways of dealing with this. Okay, so given the x values, what we want to do now is find the y values. Okay, so here we have it. I'm just going to solve this equation for y. So the question is, what if you can't solve it for y? Well, that's another issue, but okay, we can solve this for y, right? And now what we can do is we can plug in the x value, right, and obtain the y value. So if we plug in minus 2 for the x value, we get the y value, minus 5. If we plug in minus 1 for the x value, we get minus 3 for the y value. If we plug in 0 for the x value, right, I'm just substituting back into our equation, I get minus 1, and so forth. And so what I have here really is well, not the actual solution set. I just have 5 points in that solution set. There are infinitely many x, y values that make that equation true. I have 5 of those. So you see what's happening here. If I want to graph an equation, what I do is I convert it into the problem that we already know how to do. I find all the xy pairs that make that equation true, put them in a set. It's called the solution set, but put them in a set. And from the previous example, I know how to graph a set, right? Graphically represent a set of ordered pairs. So that's the idea here. So what I'm going to do now is I'm going to graph the solution set the same way we did before. Now there's one point, right? The -2, -5. Here's a second point. -1, -3. Third point, 0, -1. Fourth and fifth points. Now again, like our first example where I had the circle and we just took 5 points, was it enough? Now, if you're going to fill in the line here, you're guessing, right? What does that look like? You want to guess it's a line. It looks like a good guess, but are you sure? I mean, that's a pretty big commitment, right? So are you sure about that? See, that's why I have the ... dots in the set, because I want to remind you that there are infinitely many points we haven't found, right? We only plotted 5. When you draw this red line over here, you're saying that on that line is an XY pair, right? And that XY pair belongs in that solution set. We didn't write it down, but it belongs in that solution set, and therefore it makes the equation true. So you're stating quite a lot by drawing that line. And in this case, it is a line, and we'll come back and look at that as one of our special cases later, so we do know. But I mean, again, at this point, we've only plotted a few points. Now, what's the danger with that? Well, let's look at the next example. So in graph, we have another equation, okay? So we'll do the same thing. Again, I want to always stress, we're going to do problems in the same way. You're free to come up with your own way. You can shortcut, whatever, but you should have a process. Again, we want the solution set, and that's a set of all ordered pairs that satisfy the equation, right? So I'm going to make a list, x, y, right? I'm going to put in the x's. Right? I mean, I'm putting in the x's. I'm going between -3, 3. And I'm calculating the y values by substituting them into the equation. And I get a set, well, at least, 7 points in the solution set. Again, there are infinitely many points in the set. I only have 7. Okay, you can say I can do it on a computer, you get more. But it's still a finite number of points. Okay? Now, we can take that set and represent those points graphically, and you see what I have here, right? And now you have to guess what the curve is, what goes through here. Is this a line? Is this something else? A line doesn't look like too bad, it was a little sloppy plotting my points, so a line is a good guess. I mean, it looks from the data, right? From the data we have, from the points, the x values, that gives me the y values, that gives me the ordered pairs. I put the ordered pairs in the solution set. I can only do finitely many. And I represent those ordered pairs graphically, and then I draw a line through it to guess what the others are. And it's completely wrong. And this is the danger we have to be aware of. Okay, what went wrong? That's actually what it looks like. It's a parabola. And again, we're going to study this later, so we'll have that more information. I mean, what did we do? So what happened? We only plotted enough points around, right, a small y values, right, x between -3 and 3, and what we guessed looked like a line. I mean, we just plotted, didn't make a good choice of points, and that was our problem. Okay, so this is just a situation we have to be aware of, and this is one of the things we're going to stress, certainly throughout the first part of the course, right? If you're graphing the solution to an equation or later functions, how do you know you plotted enough points? How do you know you have the right points? So these are issues we'll be addressing, and I don't know. So this is what'll happen throughout the course. Now I want to get to some specific problems. Those are kind of big ideas that the course is going to concern itself with. Here's just some basic problems just to apply these ideas in a more concrete setting. So what I want to do is find the distance between the pair of points. So here are 2 points, right? And ordered pairs. Points are on the graph. Points are ordered pairs. So it's really just, sloppiness. Here's one of the points, -1, 5, and here's the second point, -1, 1. Okay? What's the distance between them? Well, I mean, that's it, d, distance. If you could just measure it, right? I mean, you'd have it. So the distance, the y value is 5, the x value is 1, I subtract the 2, and it's 4, and that's good to go. Okay, nothing too fancy, so just drawing the picture, you know, we don't always have to make things complicated, right? I mean, you can look at it and just do it. I mean, okay, so you don't always have to jump into the deep end. But now, okay, you get something like this B problem here. Minus 2 to 2 to 3 minus 6. So let's look at that on the graph. Minus 2, 2 is there. 3 minus 6 is here. And what we want is this distance. Now, this is always an interesting way to check. A lot of times in this class, for many of the problems we're going to see on tests, and I'm going to remind you this throughout the semester, you can actually check your answers. So when you take the test, you can actually check your answer, which is a helpful feature. So I mean, you could just measure this distance, put your pencil up there or whatever, and see how long it is, and then just measure it off on the axis, say the y-axis. Right? So I just symbolically drove a ruler there, and I geared the ruler up to, notice, an inch on the ruler corresponds to 0 to 1 on the axis. So if we look at it, it's about 9.5 inches, about 9.5. And again, if you just lined it up on the x-axis or y-axis over there, you'd get exactly the same thing. So if you just measured that D with your pencil roughly, you'd have a good idea what the answer is. I mean, it doesn't always have to be complicated. Why is that nice? Well, suppose you made an algebra mistake or remember the formula, wrote it down wrong. Okay, so we have a rough idea of the answer, 9.5. Now let's do it using the formula, right? You got to have a formula. So here's D, and here's our formula right here. I have to identify a 0.1. I'll just take this one. Either one can be 0.1. And I'll identify a 0.2. That's my second one. And we just have to substitute the data. So x2 is the 3. x1 is minus 2. y2 is minus 6. And y1 is 2. And again, you can see how you can make algebra mistakes with the signs here. That's why I like having ways to check your answers. And I encourage you to. Okay? And now if you just clean up all the algebra, it looks like this. So the one mistake people make is with signs. Writing the formula wrong with the pluses and the minuses, messing up the signs, and then not doing this calculation. I'll come back to this in a moment. The square root is a big mistake here. Okay, so square root of 89. Now, okay, you say square root of 89, what is that? I mean, okay, it's about 9.4, right? You can, just use your calculator or whatever, right? 9 squared is 81, 10 squared is 100. It's somewhere between 9 and 10. All right, so we have about 9.43, and we originally guessed 9.5. So I'm fairly confident I have the right answer. If I had made a sign with minus signs or wrote the formula wrong, I wouldn't have gotten the right answer or anywhere close, so I'd check. This is the actual most common mistake. This is not true, breaking the square root up like this. I mean, this is pretty common mistake. I mean, anyway, and you can just see, plug in some numbers for these things. So I just used 3 squared plus 4 squared, and again, this is not true, but this is common, and you can just actually calculate these two sides. On the left side, it would be 9 plus 16, which is 25. Square root of 25 is 5. And on the right side, 3 squared is 9, square root is 3, and 4 squared, 16 square root 4. And clearly, these are not equal, right? I mean, so this is another common mistake that if, again, you took the trouble to try to estimate your answer, you'd know if you made an algebra mistake. Now, admittedly, you might not know where it is, but you'd know at least to go back and maybe be more careful. So again, I'm going to encourage you throughout the course to check your work. We can do it quite frequently. Again, on most of the problems, you'll be able to check. Okay, so again, I'm going to try to point out common mistakes in the lectures and so forth. Now here's a second type of problem. Okay, the first was just a distance formula. The second is find the midpoint of the segment, whose endpoints are minus 4, minus 2, and 2, 5. And this is where graphing comes in, right? It's always, I think it's useful to look. I mean, no matter how simple the problem is, picture helps you check your answer, right? And this is a good example as well. So here's my -4, -2, and here's my 2, 5. And notice what I want is I want a segment to connect those. So that's my segment. Now, again, just look at this. I want the midpoint of the segment, right? Midpoint means, again, terminology shouldn't be your enemy. And I'm not going to make you memorize millions of words. Midpoint means the middle point. I mean, just look at the picture. You already have an idea what the answer is. So if you make a stupid mistake, it's not that you're stupid. It's like these are the mistakes you get to test back, and you could kick yourself by saying, how did I do that? It's the middle point. Look at it. The x should be somewhere about -1, and the y, I don't know, 1.5, somewhere between -2. It's not going to be 12 is the point. So if I mess up the algebra, I have a way of checking it, right? So you have to pick, just for notation, I'll call the bottom one 0.1 and add 0.2, the top one, and then you just plug in your formula to calculate the midpoint. Notice though what the formula says. What the x coordinate is the average x value, right? It's the midpoint. The x is the average x. Add up the two x's, divide by 2. Add up the two y values, divide by 2, right? It's the average, midpoint, middle point. Take the average. And if you just plug in your data, right, x1 is -4, x2 is 2, right? y1 is -2, and y2 is 5. And again, you see, great it is. You see people make algebra mistakes. Of course, it's nothing profound, but you get the wrong value. A common mistake in a problem like this is dropping the -1 and making it a 1. And you could see in the picture, if you had 1 3/2, clearly that cannot be the correct answer, right? I mean, it just simply cannot be. So you have a way of going back and checking your work. Okay, and look, it's the midpoint. The point is the distance between halfway, right? It's halfway between, right? Look, halfway between the x values. And then I can check the y's. Oh, check the y's. Actually, the line doesn't want to go. It should have gone through the point. I had a line going through 1, so I'm wrong. The line should go through the 3/2, not 1. Y is 1. At any rate, it's midway through the 2. So we have the midpoint. And again, you can see if you have the picture that it's correct. I mean, that's helpful. And our final example here is find the equation having radius 5 and center 3 -7. Again, a picture is helpful. Here's your center. So for a circle, you need two things. You have to have two things. No matter how the problem is phrased, you have to have the center and you have to have the radius. You have to. You cannot do a circle problem. They can give you the information in other ways, but whatever they tell you, draw the picture. Whatever they tell you is enough to find the center and a radius. That's what you're concentrating on. Know what you're looking for. Okay, so that's what the picture looks like. It's a circle. All right. So, I mean, again, this is more helpful, the picture, when the problem isn't so intuitive, and I'll talk a little about that at the end. So, again, center, radius. Okay, that's my radius. And I have the circle. Here's the equation of the circle. Now, x minus h squared plus y minus k, the whole thing squared equals radius squared. H and k is the center. Right, h is your x coordinate. I don't know why different books use different notation. It's fine. Some people call it x0. H is fine. I mean, whatever it is. H is 3, and the k is the -7. And you just plug the 3 in and the -7 in for the k, and just plug the radius in. For me, and my tests and stuff, leave it alone. You don't have to multiply it out. You don't have to simplify it. I'd actually rather see it this way unless I have some special way to do it. I mean, you're only risking an algebra mistake. That's fine. It's good enough for me. That's your circle. Now, why do I care about this? Because sometimes, say, you could be given different information. So instead of giving you the center point, right? Let's say I have 2 points that lie at opposite ends of a circle. Well, then you use your segment property to find the midpoint, right? So suppose I give you this point on the right and this point on the left, and that was it. So you know you need a center and a radius. How do you do it? Well, you could find the center by taking the midpoint between those 2 points, right? That would give you your center. And then you could use the distance formula, which we just did, between the center and your point on the circle. So that there's a lot of variations for this. You'll see them in the homework and stuff. So just, again, look at the picture. You always have to have a center. You always have to have a radius. Now, if you do this unit, you should be able to do a few things, right? You have to be able to determine the distance between 2 points, right? You can either draw the picture and it'll be easy to get at, or you have to use the distance formula. You should be able to find the midpoint of a segment, right? If I give you 2 points, you should be able to find a point and the midpoint of that section connecting those two, and you should be able to write out the equation of a circle as presented with certain data, center and a radius, 2 points. There's various ways you can do it. Okay, so that's really that's what you have to concrete be able to do by this unit. Okay, so that wraps up the first lecture. So good luck with the homework.